Hello, Eman.
Yes, sir.
Everything good?
Yes, sir. All good.
All right. Any doubts from the last class?
No doubt, sir, actually. I just need to, memorize the formulas so I can get it.
All right. So, did you get the assignments?
I didn't check, actually. Let me check now.
All right. Have
No,
you
sir.
checked?
I didn't get any assignments.
Not get any assignments. All right. You checked the portal, right?
Yes, sir, in the portal with the website.
All right. No worries. I'll talk to the team and see what is happening.
Okay, sir.
Till then, please try to solve this question. Right. This is the last class of Investigo. Then we'll start next chapter. Right. They are saying simplify. All right.
Okay, sir.
Formula you'll be using is the same from the last class. I'll give you a hint: tan inverse x plus tan inverse y or minus tan inverse y.
Okay.
This formula you'll be using. Yeah. Hello, Binza.
Hello, sir.
Everything good?
Yes, sir. Sorry for the delay.
No worries. Any doubts from the last class?
I have doubt from the assignment, sir.
All right. So you got the assignment, right?
Yes, sir.
All right. Let me just check what was the assignment. Yes, we gave you 2 questions, right?
Yes, sir.
All right. So what part is the doubt?
The first part is the doubt. Second part I've done.
Tan inverse 1 plus x under root this one, right?
No, sir. The previous one, not this one. This question I didn't. One question was there: sine inverse sine pi by 3. That type of questions.
Actually, I don't think they. All right. Just tell me the question. Sine inverse.
Sine inverse sine pi by 3.
Sine inverse sine pi by 3. This one?
Then 2 times sine. So I got
2
1.
times sine. All right. Sine inverse sine pi by 3. All right. So,
both the signs are in the bracket. Yeah.
Same thing. So what is the value of sine pi by 3?
I don't know, sir.
Sine pi by 3. Eman, what is the value of sine pi by 3?
Sir, 60 degrees.
Sine pi by 3.
Root 3 by 2.
Root 3 by 2. So this value is root 3 by 2. So sine inverse sine root 3 by 2. And this is very simply root 3 by 2. Right, Kinsa?
Yes, sir.
So very simple question, no worries here.
Yeah, I just got confused with the 2 sign. Thank you.
Honest. There is something wrong in this, but you don't have to think. If this question comes in your exam, just write like this. All right.
Yes, sir.
But I think that is a printing mistake. They have just given you sine inverse sine pi by 3. Let me find the question. All right, I got it. All right, Kinza, we are solving this question in this class, first question of the class. Right, they are
Yes.
asking you to simplify using the same formula we studied in the last class, tan inverse x plus tan inverse y. All right.
Yes, sir.
Have you solved this?
Sir, I found the formula, but I can't solve it.
All right,
I'm trying, but
no issues. See, in the denominator we have plus, in the numerator we have plus, in the denominator we have minus. That means we are going to use tan inverse
and
x,
a plus b.
right? This one.
Yes.
But we can see that what is the formula here, Aman?
Tan inverse a plus bx by sorry, x plus y minus 1 minus xy.
Right. So we can easily see that this question is the right part of the formula, right?
Hmm.
And Kinza, this is clear?
Yes, sir.
All right. So we have to go from right to left. How we can do that? We have to make this format. Which format? Something plus something upon 1 minus the same thing's multiplication. But we don't have this here. Why? How to solve this type of questions? We have 1 in this part, right? 1 here, but not here. So how to make that 1? We can divide by b.
By b. Yes.
So tan inverse a plus bx. If we divide by b here, then we have to divide by b in the numerator also. So b upon b minus ax upon b. This thing is clear, both of you?
Yes, sir.
Yes, sir.
All right. Now we can write this tan inverse a by b plus x upon 1 minus a by b x. Does this look familiar to this? Something plus
Yes.
something, right? So what is the value of x here? Like formula, I mean a plus b. So what is a here? A by b.
A by b.
And plus tan inverse
X.
x. So this is the simplest form. All right.
Yes, sir.
All right. Next question. Prove that sine of cot inverse cos of tan inverse x equals to x square plus 1 upon x square plus 2 under root. This looks very complicated. It's not very complicated. Why? We have always start from inside. In questions like this, always start from the inside. Cos of tan inverse x, we don't like. We can convert this cos of tan inverse x into cos of cos inverse x. Yes or no?
Sir, how?
How? By taking tan inverse x is equal to theta. So tan theta is x, making a triangle and finding the value of cos theta. Right, Aman? Remember this method?
Yes.
So tan theta will be x upon 1. So this is 1 plus x square under root. So find the value of cos theta. From there, we can write theta is equal to cos inverse of something. And this is the same theta. So we can replace tan inverse x as cos inverse something. That's something you have to find from this triangle. This is clear?
Yes, sir.
Yes, sir.
All right. Same way, you can move forward and see if you can find the answer, like prove the question. All right. solve this? Aman, Ginza?
Yes, sir. Doing it almost.
Almost. All right. Ginza?
Yes, sir, almost done.
All right. All right. Let's see.
Sir, for cot inverse x, I'm getting 1 by root 1 plus x squared.
Cot inverse 1 upon 1 plus x square. You are getting this value?
Yes, sir.
All right. Kinza, did you reach to this point?
Yes, sir.
All right. Now we can do the same thing again, right? See, for this, how did we solve? We converted tan inverse into something cos inverse, right?
Yes, sir.
Now this is the same question, right? But instead of sine, we have cos. Instead of cot, we have instead of tan, we have cot. So again, we can convert this thing into sine inverse of something. Yes or no?
Yes, sir.
Right? How? By creating another triangle. Assume cot inverse this is theta. So cot theta is this. Make a triangle and find the value of sine inverse. Put the value here. You'll get the same result. This thing is clear or not?
Sir,
Yes.
can you do it, please?
All right. Cot inverse 1 upon under root 1 plus x square. Let's assume this is theta, right? Because cot inverse will return a value. I assume that is theta. So I can write cot theta is 1 upon 1 plus x square. This is clear, Aman?
Yes, sir. It's clear.
Now, if I create a right angle triangle and I say this is theta, then cot theta is what? Base upon perpendicular, right?
Yes.
Or adjacent side upon perpendicular side, whatever you remember. So cot theta, I can write this upon this. So this I can assume is 1 and this is 1 plus x square under root. Yes or no?
Yes.
Because if this is theta, then cot theta will be 1 upon this. So we got the same value. Now, by using Pythagoras theorem, you can find this hypotenuse. What will be the answer here? What will be hypotenuse?
1 squared plus root of 1 plus x squared squared, the whole.
So what will be the final answer?
1 plus x squared.
Right. So 1 plus x square is 2 plus x square. Yes or no?
Yes.
So now I can find sine theta. What will be sine theta in this triangle? Why sine theta? Because in the question I have sine of something. That is why I'm finding sine theta. So what will be sine theta here? There will be
One.
under root
Yes.
also, right? I forgot the under root. Under root also. Yes, sine theta will be
Root 1 plus x squared by root 2 plus x squared.
absolutely right. So what can I write? Theta is equals to sine inverse, same thing, 1 plus x square upon 1 plus 2 plus x square under root. Yes or no, Aman?
Yes.
So instead of theta, I can write this sine inverse something. And what is theta? Theta is cot inverse this. So instead of writing this, I can write this value. This is clear or not?
Yes.
Kenza, this is clear?
Yes, sir.
So in the question, sine of cot inverse this value, and I just proved that this is equals to this. So sine inverse 1 plus x square upon 2 plus x square under root, and this is 1 plus x square upon 2 plus x square under root, which I think is the RHS. Yes or no, everyone?
Yes.
This is the RHS. Very simple. Just the triangle method 2 times, and the answer is in front of our
Okay.
eyes. All right. Please note it down. All right. We have next property. And this is also very important. In the next chapter, continuity and differentiability, you have to use this identities a lot. All right. So instead of 2 tan inverse x, we can write sine inverse 2x upon 1 plus x square. 2 tan inverse x is equals to cos inverse 1 minus x square upon 1 plus x square. Instead of 2 tan inverse x, we can write tan inverse 2x upon 1 minus x square. Please note it down. This is please star mark also, or whatever you do to note it down. Whenever you see sine inverse 2x upon 1 plus x square, you can directly substitute the value as 2 tan inverse x. All right. Why? Because this is the formula for sine 2 theta. Sine 2 theta is, can anyone tell me what is sine 2 theta?
Two sine theta cos theta.
Yes, absolutely. And there is another formula for that also of tan theta. Two tan theta upon 1 plus tan square theta is also sine 2 theta. If somebody asks you to prove, then put the value. Whenever somebody asks to prove this kind of question, that 2 tan inverse is this is equal to this, then always look at the left side. This you have to do, then you have to put the value this as theta and use the formula for sine inverse. What I'm saying, we have two sides, LHS and RHS, right, Aman?
Yes, sir.
So always assume this value, tan inverse x is equal to theta, because in this type of question you'll always have to assume something. So always assume the left hand side quantity, tan inverse x is theta, and use the formula of right hand side quantity, sine. Then you can easily prove. All right.
Okay, sir.
So always do this and your question will be clear. So to prove this, we can write sine 2 theta. Sine 2 theta is, because we need the formula for tan, we can write 2 tan theta. And this formula you have to remember, otherwise there is no scope. So instead of tan theta, we can put x, so 2x upon 1 plus x square. Now this sine comes to that side. So 2 theta is sine inverse 2x upon 1 plus x square. Now what is theta? Tan inverse x. So 2 tan inverse x is sine inverse 2x upon 1 plus x squared. This thing is clear. How to prove? All right.
So can you explain again the proving part?
All right. Whenever they ask you to prove something in this type of questions, look at the left hand side and right hand side. All right. Now, always assume the left hand side quantity as theta in inverse function. All right. If somebody says prove that 2 cot inverse x is equal to something something something, then to prove that you have to assume cot inverse x is equal to theta. Because two ways to prove this. We can assume tan inverse x is theta or sine inverse x is theta. So what to choose? Tan inverse x is theta, the left hand side quantity. And the formula is saying sine inverse something. That means we have to use the formula of sine 2 theta. Why? Because we have 2 tan inverse x. So sine 2 theta. If we had 3 tan inverse x, then sine 3 theta. This thing is clear, Kenza?
Yes, sir.
So sine 2 theta is 2 tan theta upon 1 plus tan square theta. We can also write 2 sine theta cos theta, but this is not needed. Why? Because we are solving for tan inverse x, right? So it doesn't make sense to write sine theta cos theta. So 2 tan theta upon 1 plus tan square theta. This formula you have to remember of sine 2 theta in tan form, cos 2 theta in tan form, tan 2 theta in tan form. So this is in sine 2 theta is 2 tan theta upon 1 plus tan square theta. What is tan theta? If tan inverse x is theta, then x is tan theta. So tan theta, wherever I see, I put x. Now this sign goes to the right hand side. So 2 theta is sine inverse 2x upon this. Now again putting the value of theta as tan inverse x, we got this formula. This thing is clear, Kinza?
Yes, sir. Thank you.
All right. For cos 2 theta, you can remember the formula by this also. Wherever you have x, just put tan theta. So 1 minus tan square theta upon 1 plus tan square theta. All right. Or vice versa also. If you remember this formula, you can find this formula very easily. If you remember this formula, you can find this formula very easily. And same thing for tan 2 theta. Can anyone tell me what will be the formula of tan 2 theta? Just look at this.
So same 1 minus tan squared theta.
No. Wherever you see x, you have to put tan theta. So 2 tan theta upon 1 minus tan square theta. Aman, you have to look at this. We are not talking about inverse, right?
Yes.
Just normal trigonometric functions. Kinza, this thing is clear?
Yes, sir.
All right. Note it down. Done?
Yes, sir.
All right. So let's solve few questions. Tan inverse x minus 1 upon x minus 2 plus tan inverse x plus 1 upon x plus 2 equals to pi by 4. They're saying solve. All right. So until now we have seen the questions like find the value or simplify. This is saying to solve, and to solve means find the value of x. What is the value of x, right? Somebody gives you a quadratic equation and says solve. So what do? You find the value of x is 2 and 3, right? Yes
Yes,
or
sir.
no? Right. So same thing is here. They are saying find the value of x. So what to do? What formula we can apply here? What formula comes to mind? Aman, Kinza, what is the formula here we can apply? Can we use tan inverse A plus tan inverse B? Yes or no?
Maybe, sir.
Right? See, there is no other way. What else we can do? Nothing. Right, Aman? So this is the way to go. Just put the value tan inverse A plus tan inverse B. Then you will get tan inverse something something is equals to pi by 4. So this 10, if it goes to right side, you will get 10 pi by 4, which is 1. So this x quantity will be equals to 1. Now this becomes a simple mathematical question which you can solve. All right. Yes or no? Do you want me to
Yes,
solve
sir.
this? All right. So you
Yes,
guys
sir.
can solve this, right?
Yes, sir.
All right. I'll give you a few minutes. solved it? Aman, Kinza,
Still in the last step.
Kinza, what about you?
Doing so.
All right.
Got it, sir.
All right. So no doubts in this?
No, sir.
What is the answer you got?
Root 1/2.
Right. Plus minus, I think x square equals to half you must have got. X will be plus minus 1/2, right?
Yes, sir.
All right. Aman,
Yes, sir, I got this same answer.
all right. So no need for me to solve this.
No, sir.
Let's see next question. See, these are a few like difficult, not very difficult, but calculations is very lengthy, right? So these are few questions they can give you. Next question is tan inverse 2x plus tan inverse 3x equals to pi by 4. Again, solve. That means find the value of x. Very similar question. Solved it?
Yes, sir, I think.
All right. So what is the answer you are getting?
So x can be 1/6 or x can be -1.
Let
Two answers. Because it's in the
can be
quadratic formula.
right. Actually, I don't have the answer here. So I believe you must be right. Or do you want me to solve this?
Okay, so you can solve it.
All right. Kinza?
Yes, sir. I got the same answer. 1/6 or
Understood.
1.
All right. Then we can move on, right? No need to solve. Both
Okay,
of
sir.
you got the same answer. All right. So next question. Sin inverse sin x plus cos x upon √2. This is the question where they try to confuse you. But you should not be confused. Why? Because we are trying to solve different type of questions. Right? Very simple. This type of questions, how to simplify sin inverse, wherever you sin a plus cos a, find maximum value, minimum value, anything related to this. There is only one way to solve, convert both of them to sine. And how to do that? Not writing cos is 90 minus a. No. We can divide this √2 as 1 upon √2 sin x plus 1 upon √2 cos x. Yes or no? Both of you, this is clear.
Yes, sir.
I just separated √2.
Yes,
Now
sir.
I need, this is sine inverse, so I need sine of something, right? So that I can write this easily. Sine inverse, what is the value? Where do we get 1 upon √2? Can I write this as cos pi by 4? Yes or no? Cos pi by 4 is 1 upon √2.
Yes, sir.
And this is sin x plus, can I write this as sin pi by 4?
Yes.
So what is this formula? Cos a sin b plus sin a cos b. What formula is this? Sin a cos b plus cos a sin b is sin a plus b. Right, everyone?
Yes, sir.
So I can write like this: sin a cos b plus cos a sin b sin a plus b. So the final answer will be x plus pi by 4. Is this thing clear?
Yes, sir.
All right. Now suppose you had cos inverse something. So nothing would change. Just write sin pi by 4 here and cos pi by 4 here. Why? Sin a sin b plus cos a cos b is cos a minus b. And you have to remember this formula at least to solve this type of questions. All right, Aman, Kinza, this is clear?
Yes,
Yes,
sir.
sir.
All right, note it down. This is the next question. All right. So we don't have sin inverse A plus sin inverse B formula, right? So what we can do, again, by using triangle method, we can convert this into tan inverse something, and same thing about this, and same thing about this. And if we can convert this into tan inverse, then we can use the formula tan inverse A plus tan inverse B and prove that LHS equals to RHS,
Okay, sir.
right? Kinza, this is clear?
Yes, sir.
All right, then try to solve this. solve this?
No, sir.
Are you solving this or stuck?
Sir, stuck.
All right, let's see. Have you converted all of this into tan?
Yes, sir.
So we can write this as tan inverse 3 by 5, 3 by 4.
Yes, sir. 3 by 4.
Right. This is tan inverse 8, 8 by 15.
Okay, sir.
This is right.
Yes, sir.
Yes or no? All right. So this is sine inverse. This you have to tell me. I cannot solve this mentally. 85 square.
Okay, sir. I think that's where I made a mistake somewhere.
All right. I'm not saying this is correct. This I might be wrong. So please check your calculation because I did not calculate this. I'm just looking at the values and saying. But I think this is 17 square is 289 minus 64, 225, so 15, right? So 8 upon 15, I think is correct. Kinza, are these values correct or not?
Yes, sir.
And what is on the right side?
It's 77 upon. I'm just doing that. Just 1 minute.
So you guys have just like converted these values.
Yes, sir.
Very slow, very slow. 3, 4, 5 is a right angle triangle. 18, like 8, 64 squares. This is very easy, right, to convert. And this step, let me tell you, 85 square is, let me calculate. 80 square is 64 and so on. Just tell me. I don't want to find
Sir,
the square.
7225.
7225 and 77 square is 25 52 and 27 squares. What is the square of 27?
5929.
5929. So 7 7 2 5 5 2 2 9. Just subtract this, you'll get the answer. All right, find the under root. There was a trick to find the squares. Let me remember. That would be helpful in, yes, in numbers less than 50. Do you guys want to know this, or tricks are not that very useful, as you can see in this question? Anyone interested in knowing how to find square easily?
Yes, sir.
Yes, sir.
But that should be number should be less than 50. There was some other trick to find numbers near to 100 also. I'll check and tell you. So if number is suppose 49, how to find square? How much less is this from 50?
1.
So subtract 1 from 25. So for 24. Yes.
Okay.
And 1 square is 1. So 0, 1. This is the square.
Okay.
This thing is clear.
Yes.
All right. Please check the answer. I believe I am right, but I may be wrong because I read this trick very, very long.
Sir, can you show it again?
Let's take 47.
Yes, sir.
How much less is this from 50?
3,
So 25 minus 3 is,
22,
and 3 square is,
9.
this is the square.
Okay,
Sir, for 49, it's correct.
So this will be correct for this also. Okay. So very easy trick this is, but this you can do this with more than 50 also. But see, because this number is a lot more than, so we have to find 27 square is, so no point in doing that. But suppose you have 60, so how much is this more from 50? 10. So 25 plus 10 is 35. 10 square is 100. So what will happen? 100 like this. So 3600. We know 60 square is 3600. All right.
Yes,
Okay,
sir.
sir.
So you can do this. If 3-digit comes, then just add this to the previous one. So this is the small trick. But rest of the question you can solve. Yes or no?
Sir,
Yes, sir.
I can't find the root
You can't find the root.
or this answer because this a number is 2496.
2496. 2496. I don't think there is a root for that. 2496. Don't worry, just write under root 2496. You'll get the same value from here also, if this is true. All right, but 2496 I don't, because 2500 is a square, right? 50. So 2496 will not be a square.
Yes, sir.
So please check if these numbers are correct or not, and the subtraction is correct or not. Then look at the number.
Okay, I'll check again.
Yeah. Right. There is one other method to solve this question also. We have sine inverse. Yes, Aman?
I found that the root for 77 is 5929.
5929. All right. Yes, so please subtract this again and find the, let me tell you another, this method is clear to you, right? Just finding the square root and square is you are facing difficulty, otherwise this is full.
Yes, sir.
All right, but if you cannot find root at home also, then ask me in the next class. All right, we'll take some time and find the roots. Otherwise there is another method to solve this. How? Let's take this as A. All right, and this is B. So what I can write this, 3/5 is sine A and 8/17 is sine B. This thing is clear.
Yes.
I told you before also, if you have any question to prove this and that, this is sine inverse 77/85, then always assume the left side as theta and use the formula of right side, right? Yes or no?
Yes, sir.
Both of you. So if we have A and B like this, so what we can do, can I write sine A plus B? Why so? Because I want to have A plus B on my left side. So I use the formula sine A plus B. So what is that? Sine A plus sine B. Oh, sorry, sine A cos B plus cos A sine B. Right? Now I have sine A, I have sine B, so I can find cos B and cos A also. Yes or no? Both of you, yes or no? If you have sine A, can you tell me the value of cos A? This identity, sine square A plus cos square A is 1,
Yes, sir.
right? Or you can draw the triangle, whatever you feel good. So we have sine A and sine B, so we can find cos B and cos A. Just put the values. So if sine A is 3/5, then cos A will be 4/5. This we already have, 15/17, plus this is 4/5 into sine B is 8/17. All right, you get the you check the values. This will be correct because we already solved for that.
Yes, sir.
So 15 into 3 is 45 upon 17 into 5 is 85. 4 32 and 85. So this is 77 upon 85. So sine A plus B, we are getting 77 upon 85. So A plus B, we will get sine inverse 77 upon 85. What is A? Sine inverse 3 by 5. And what is B? Sine inverse 8 by 70. So this we can easily prove by this method also. All right.
Okay, sir.
Yes, sir.
I'll write it down.
Yeah. So whatever you feel good, you can choose any method. But for this, you have to remember which formula you use. So you have to use some observation skills. In the previous method, you just have to use your finding the root skills. All right. Note it down. Done, everyone?
Yes, sir.
Yes, sir.
All right. So 2-3 questions are left. After that, this chapter will be finished. So next week you will have a test of this chapter. All right,
Okay.
half an hour test. So prepare accordingly. All right, Kinza.
Yes,
Clear?
sir.
All right. And on the next class, we'll start continuing differentiability. So what you have to revise? You have to revise the basic differentiation of class 11, right? Product rule, quotient rule, differentiation of sin x, cos x, and so on.
Okay, sir.
All right,
Yes.
basic, nothing more. And even if you can do that, then just tell me in the class. Be honest. I'll tell you. All right.
Yes, sir.
Okay, sir. Thank you.
Yeah.
Thank you, sir.
And revise this. I need you to score really good in the next test. All right.
Yes,
Yes,
sir.
sir.
All right. Then take care, guys.
Thank you so much, sir.
Thank you, sir.